Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at simplifying radical expressions with product property of exponents. So we need to first review exactly what is the product property. In previous lessons, many years ago, or many months, or whatever it was, we learned the following, that when you have a, b to the n like this, you can split it apart where you have a to the end and b to the end. This is called the product property of exponents, or product power of powers, whatever you want to call it. This is the basic principle. And this ideal holds true also when you're dealing with radicals, or roots, if you will. So if I have the following, where I have n here as my index and a and b as my radicand, this can also be factored out, if you will, if you want to call it that, where you have the index of n with the radicand of a times the index of n and the radicand of b. It's the same idea. And so what we're going to do in this video is we're going to look at several examples of how this can be applied. So why don't we start with the first one, rather simple. And essentially what you do here is that you split apart your number. So let me show you what I'm talking about. You factor your number. So let me give you my example. I don't want to get too theoretical here. Let's say I have the square root of 288. Now I want to simplify it following this example up here that I just showed you a few moments ago. Now, having said that, in order to do that, I need to factor this, because remember, in my example, I already have the two separate constants, if you will, the two separate numbers, but here I don't have two separate numbers yet. So what do? Well, I do a factor tree where I try to figure it out. So what happens is this: when I find a perfect square, I'm going to use that. And let me do it so that you can understand, and then I'll try to explain it afterwards. So 288, we can factor that as 144 and also 2. Now here's the thing. This is what's going to happen. 144 and 2 is perfect. Let me show you what happens here. So I have here the square root of 144 times the square root of 2. Now if you find what is the square root, or what is the second root of 144, well, again, if you know basic multiplication tables, you know it's going to be 12. So this simplifies to the following. Let me just draw the arrow down here so you know where we're going here. This simplifies to 12 times the square root of 2. You don't really need the times. 12 times the square root of 2. That's what it is. So this right here is the simplified answer right here. And so you're always trying to look for a perfect square when you're dealing with a square root. If you're dealing with a cube root, you're going to look for a perfect cubed, if you will, or I don't know exactly the technical term for that, but let's go ahead and take a look at an example where this can be worked out. So this time we're dealing with the following. We're looking for the cube root of 81. In other words, we're looking for a number, or we're looking for a way to reduce this in a simplified manner. So again, we break out our little factor tree here. Now here's the thing. We're looking for a perfect cube root. In other words, we're looking for a number that when you multiply it by itself 3 times, it'll give us the product of something. That's what we're looking for. So I break this down like so, and so I would put 27 here and put 3 here. Now here's the thing, just from being familiar with multiplications and numbers, I know that 27 is a perfect cube root. In other words, there is a number that when you multiply it by itself 3 times, you will get 27, and that number is 3. So here's how it works now. Let me see if I can make this clear. I'm going to draw an arrow right here. So this is what we get. We get the cube root of 27 times the cube root of 3. That's what we get. Now, this simplifies right here to as follows. 3, and then we have the cube root of 3. This is our answer. And you can see how this works out. Because, how did I get the number 3 here? Because it's very simple. I just want to make sure everything is clear here. 3 times 3 is 9. 9 times 3 is going to be 27. That's how we got that. And so when you take the cube root of 27, you will get the whole number of 3. And then this was already simplified as much as possible. And this becomes our final answer like so. That's how that works. Now with this next one, we're going to deal with something that involves only variables. And this is where it gets a little bit more unique. So let's say I have the following. I have the square root of b to the 5. Now, how do we do this? Now remember, if we don't put the index, it's 2. That's basically how it is. So what we can do here is that if we can find a way to make a radical that has the same power inside, or the same power for the radicand, as also that's the same root on the radical, if you will, they will cancel out each other. We learned that in a prior video, and we'll have a simplified answer. So let me explain that as simple as possible. This is what we would do. We would take b squared times b to the 3rd power. And you guys know that when you multiply them like this, they add together. That's what we're talking about here. So going back to this, they will add together. We've talked about this in simplifying stuff in prior videos. We can't review everything in every video. Now, here's the thing. Now, this is where it gets very, very important. Of course, we have the 2 here. I didn't write it, but we have the 2 here, and we have the 2 here. They basically destroy each other, and we're left with the following answer: b times b to the 3rd power. That's our answer, like so. But remember, now this is where you have to be careful. It has to be, I believe, the absolute value. Yeah, the absolute value, because this was originally an even exponent. So we have to make sure we put the absolute value sign. Again, maybe not had to be that strict, but it's a good practice to do that. Now, for our final example, we're going to deal with a variable, but this time with the cube root. So let's just move to the next slide here. And so this is what we're working with here. We're working with, we're working here with y to the 5th power, the cube root of y to the 5th power. And so this is what we're going to do. Now, last time we wanted to try to separate out something where we had a square and a square root. This time we want a cube and a cube root. That's what we want. So with that in mind, this is what we will do. We will have, let's see here, y cubed to the 3rd power, like so, times y cube root to y squared, like so. Now, like I already told you previously, these 3's, they destroy each other, and you essentially end up with y, and then you have the cube root of y squared, like so, and that's done. So, in this video, we covered a lot of complex things. Let me review what's been happening, and then we'll conclude the discussion here. So, we were learning about how to simplify radical expressions using the product property power of exponents. And so we reviewed how that works is that when you have a to the b to the n, you can split them out like this. And the same ideal applies with the radicals. If you have the nth index under the square root or the radical of a times b, you can split them apart like so. And so the first example was basically where we did this. We had the example of the square root of 288. We factored out a little bit, so 144 and 2. And the thing is, 144 is a perfect square. Beautiful. And that simplifies to 12, and we don't mess with the second one. We just do 12 times the square root of 2. In the second one, we dealt with the cube root. And so this time, we wanted to find a cube, a perfect cube, if you will. And if we're able to do that, it'll simplify. Sometimes you can't do that, but in all these examples, we were able to do that. And so when we had the cube root of 81, we factored out 27 and 3. 27 was a perfect cube. In other words, if you cube root it, you'll get 3. And then we left the second one alone as it was. That's how it worked out. And then in this next example here, we were working just with variables, so we didn't have any numbers this time. And basically it was the square root of b to the 5th power. And so we factored it out. But when we factored it out, our goal was very clear. We want a square and a square root together with the same number. So the index and the exponent need to be the same number, in other words. And so we found that b squared will work in b to the 3rd power. And then we got our answer here. The absolute value of b times b to the 3rd power. It's the square root of b to the 3rd power. And the reason we have the absolute sign is because the original exponent was even. That's why we did that. And then for the last one, it's dealing with a variable again where we don't have any numbers, but this time it's cube root. And we just follow the same process, so I'm not going to explain that too closely here. So I hope that this video was useful and that you were able to understand the different processes that we were using to try to simplify, radical expressions with the product power property, or the product power property, excuse me. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.